Names in organic chemistry follow the general format for names of human beings. Usually, our names have a title, we have a given name, and then we have a family name. This is the format that most organic names follow as well. Of course, there will be some exceptions, just like some people have middle names or some people have more than one family name. All of this will become more clear as we take more examples. Let's start with alkanes. Alkanes come under the category of aliphatic hydrocarbons. Aliphatic means that these are chains. The chain could be cyclic or acyclic. For example, here is a cyclobutane, or you could have a straight chain. Alkanes contain only single bonds. They contain the maximum possible number of hydrogens per atom of carbon, and all members of this family have names ending in "ane." So this is their family name. So for the alkanes, this prefix indicates the given name. This comes from the number of carbon atoms in the chain. The "ane" ending is the family name. We do not have a title to begin with, but as and when we see one, I will tell you about it. So let's look at some examples. If you had one carbon atom, the given name would be meth. The family name is ane. So the name would become methane. Since you have only one carbon, and these are hydrocarbons, and if hopefully by now you know that the bond capacity of carbon is 4, so each carbon needs to form 4 bonds, and because these are hydrocarbons, the only other thing you can have is hydrogen. So you would have one carbon surrounded by 4 hydrogens. Of course, you've done your Vesper theory in grade 11, so you know that the structure would actually be these 2 hydrogens are in the same plane, and then you've got one that's coming out of the plane and one that's going into the plane. Like, you can draw it that way too, but usually in organic chemistry, we don't take away marks for someone not showing us the 3D geometry of the molecule. It's always a good idea if you do, but while you're learning, you can keep things simple and leave this alone. So this is your structural formula. So let us look at the second member of the alkane series. You would have 2 carbon atoms, each with 4 bond capacity. Fill up as many hydrogens as you can, ends up being 6 hydrogens. And the thing to keep in mind is that in organic chemistry, unlike in inorganic chemistry, 2 does not become di, but in fact becomes eth. Family name ane, put them together, the name becomes ethane. So let's very quickly take a look at propane. It has 3 carbon atoms. Prop is the prefix for 3 in organic chemistry. Again, it is not tri as we do in inorganic chemistry nomenclature. At this point, it is a good idea to take a look at other representations of alkanes. So we have the structural formula, which shows the actual connection of the various atoms in the molecule. Another way of talking about this same molecule could be by using its molecular formula, which only shows the number of each kind of atom in the molecule, does not show anything about how those atoms are bonded. You could show the condensed structural formula, which is similar to the structural formula. It's just a more compact way of writing it, just like the name suggests. So for ethane, it does not matter if you write CH3 or you write the H3 first and then the C. You can also show a dot or a line, depends on what your teacher asks you to do. All of these would be okay. Or you could draw a line diagram. The important thing to remember in the line diagram is that your points represent carbon atoms. The hydrogen atoms are not shown. It is simply assumed that each carbon atom has as many hydrogens as are needed to fulfill its bond capacity of 4. The lines are the bonds between 2 carbon atoms. Again, you could very explicitly show the dots as carbons, or you could just leave it open as a simple plain line your teacher will understand. Propane, we write the molecular formula as C3H8. You can write the condensed structural formula using dots or lines or nothing in between. And you can draw a line diagram in this zigzag shape. The reason for this zigzag shape is the 3D geometry around each carbon atom. So remember that each carbon atom has a tetrahedral geometry. We are not showing the hydrogens, only the carbons. So continuing with this idea, let us fill in this table. When you have 4 carbon atoms in a straight chain, you get butane. The prefix is but, it is not tetra. 4 carbon atoms can accommodate a maximum of 10 hydrogen atoms. Here is your condensed structural formula and then the line formula. Similarly, for 5 carbon atoms, you would get a pentane, C5H12. I am not doing the middle ones, straight away going to the line diagram. If you need, you can write numbers on top of those dots for the carbon atoms. So you have 6 carbon atom chain, a 7 carbon atom chain, hexane and heptane. 8 carbon atoms would be octane, 9 carbon atoms would be nonane, 10 would be decane. Go ahead and fill in your molecular formulas. Let's take a second and complete the table for propane, ethane and methane as well. So a question you might want to ask yourself is, how are the molecular formulas related? What happens as you go up by 1 carbon atom? Most likely you have seen the trend and you see that for each step you add 1 carbon atom and 2 hydrogen atoms. This kind of a group in organic chemistry is called a homologous series, which is a fancy way of saying that all members of this series can be represented by one general formula because each member in the series goes up by a certain unit. In the case of alkanes, each member goes up by the CH2 group. We have already talked about the other parts. The Vesper geometry at each carbon atom is tetrahedral. The bond angle at each carbon is 109.5 degrees. And you might have already figured out the general formula for the alkane series is CnH2n plus 2. So if you have 1 carbon, that means the hydrogens would be 2 times 1 plus 2. 4 hydrogens, and so on for all the other members. So this here is the rules for naming simple straight alkanes, the first few members of this series. We will next look at how to name branched alkanes.